Okay, so a little review of precalculus. You know, y equals x squared or x equals y squared gives you a parabola. If it's y equals x squared, it opens up or down. If it's x equals y squared, it opens to the right or left. It's got a vertex, extreme point. And the vertex in this case would be through the origin. If you replace x by x minus h, y by y minus k, and again precalculus, for reasons you should understand, that moves the graph you get from this form so that the vertex is at the point hk. It moves every point, h units in the x direction, k units in the y direction. Okay. And then if you put some number in front of the x minus h squared or the y minus k squared, that is a vertical stretch, basically. That's not vertical, so it would be a horizontal stretch in this case, or a vertical stretch in this case. Could be a reflection. If A is negative, it'll be a reflection. And you can use the word compression if A happens to be less than 1. Now, you should lay this back and make sure you review so that you understand all of that, because you won't need it just in this course. Okay? You can also use horizontal and vertical stretches to understand why the derivative of f of x is the same as the derivative of f of x plus k. You're just raising the graph k units. The slope's going to be the same at every x value. So I think that ought to be reinforced in the calculus course. It's very easy to say it and remind people that most calculus courses don't do that. Okay? Texts don't do that. Because I think maybe we just assume that nobody learns anything in precalculus anyway. Okay? I remember when I took this course, well, when I started calculus, I hadn't had precalculus. So I had to figure out all the precalculus as it came along. So you're kind of in a similar situation if you don't remember this. But this is fairly easy to figure out. You've got to powder it a little bit, but you can review it. Okay, so that's what we have. And then if you have this form, just a quadratic x, let's say, or a quadratic here, that you can complete the square on the ax squared plus bx, and then this becomes this. Put this in this form, just completing the square on the x terms. Complete the square on the y terms, and you put it in this form. Okay? So, that's parabolas. They're fairly easy to draw. Now, general quadratic form with 3 variables. Quadratic in x, quadratic in y, quadratic in z. You complete these squares. Just looking for a good letter to use here. Not a great one, but I'll use it. Okay? So, by completing the square, you get this kind of general form, except that could be that A is 0, or C is 0, or E is 0. If any of these things is 0, like if C is 0, then you're not going to have a y squared. You're just going to have a multiple y here, okay? Which means that this thing will be parabolic in y, because that's just like this form. Okay? So if any of them is 0, then that corresponding form is going to just have a first power, okay? And it's going to give you a parabolic nature. Now we're going to go over the possibilities here. Before we do, we've got to talk about ellipses and hyperbolas. So, not available. Well, actually, that's nothing. Standard form. Ellipse has a form x squared over a squared plus y squared over b squared equals 1. Hyperbola has a form negative x squared over a squared plus y squared over b squared equals 1. If a and b are the same, then this is just like x squared plus y squared equals r squared, which is a circle, okay? So if a and b are equal, this is a circle. But here's how you draw an ellipse. Now I'm skipping a lot of stuff, but you got to review it. Okay, so here's the ellipse centered at the origin. Very easy to draw this. Okay, now what I've drawn is a rectangle, not an ellipse. But the rectangle is very handy because it gives you a guide for drawing the ellipse, and the ellipse is just like a circle that's elongated in one direction or another, or maybe not elongated at all, in which case it's just plain circle, okay? If A equals B. So your ellipse, let's make a pretty blue ellipse here. It's tangent to the rectangle at these 4 points. Not doing a very good job here. Kind of screwed up in this quadrant. The other 3 quadrants look okay. Sort of okay. Okay, there it is. That's not a problem at all. Okay. Now over here, hyperbola starts out with the same picture. But now, you do 2 things. What you do is you draw a line through the corners, the opposite corners of the rectangle. You draw a line through opposite, you draw 2 lines. There are 2 possible ways you draw a line through opposite corners. One way is this way, and one way is this way. Now, tell me what you think. Don't say anything because we don't want your voice on the video, although you got a great voice. Okay. Is it possible for this hyperbola, the first one, x squared over a squared minus y squared over b squared equals 1, is it possible for that parabola to go through the point 0b? Thumbs up or thumbs down? Well, what do you get if you substitute 0 for x and b for y? Get -1 on this side, 1 on this side. Right. Okay? Now, if you substitute the coordinates of the point A, 0, what do you get? What do you get on this side? Yeah. So that works, right? Well, that's important. I understand that. It's easy to understand. And if you don't know that, then it's hard to figure out which one is which. Now, on this one, if you substitute 0b, what do you get on the left-hand side? Yeah. No. 0b. 0 for x, b for y. Yeah, you don't want that negative in front of it. Good. Okay? And similarly, if you were to substitute A0, you'd get, yeah, okay? So you know which vertices this thing goes through, okay? So in this case, this will be a vertex, and of course you substitute -a since you're squaring x, still equal, you still get 1 equals 1 up here, right? So now we can draw the parabola. For this equation, the hyperbola, sorry. Now, hyperbola looks a little like a parabola, but the hyperbola has asymptotes. Okay? Parabola doesn't have asymptotes. Parabola keeps getting steeper and steeper, and there's no limit to how steep it can get. Hyperbola, there's a limit to how steep it can get, and that's what these lines are. So we go through this point, and it kind of looks a little like a parabola, but it's asymptotic now to these 2 lines. And of course, we get the same thing on this side. Okay? This hyperbola going just the same way, except, well, that's a bad piece of chalk, isn't it? Let's see if I can get that. Yeah, it doesn't want to write it all. Let me turn it around to the broken end there. That's better. Okay? It's going to be through this point. And this point. It comes out asymptotic. The same two lines, but on the other side. Well, that's not hard to understand. Now, of course, if you had x minus h squared and y minus k squared, the center would not be the origin. The center would be the point hk, wherever that happens to be. We just move the whole thing over to hk, and there it is. You're not going to have to worry too much about translating these things. Most of them will be through centered at the origin. Okay, well, let's now consider what happens if you have an equation, and where the general equation is of this form. So we can see that, for example, if A is positive and C is negative, then as far as x and y are concerned, you have a hyperbola. You know, in other words, if A and C have opposite signs, you're going to essentially have one of these, but of course, it'll be x minus h squared, y minus k squared, right? Okay? So it's possible for the x and the y to give you a hyperbola, but then if you've got a non-zero e, then the sign of e is going to match one of these. So let's say A is positive and C is negative. Okay? Then your parabola in the xy plane, or your hyperbola in the xy plane would be like this. Okay? Then if E is also positive, then as far as x and z are concerned, you have an ellipse. Well, that means down here in the xy plane, you've got this hyperbola, okay, actually like this and like this. In the z plane, you've got the xz plane, you would have an ellipse, okay? Now let's see how this works out and how we can kind of understand this and even sketch these things. Let's say you have the equation we're going to go to 9x squared minus 4y squared. And I want this to equal something that's multiple of all those numbers, and the smallest multiple of all those numbers is 900. Okay. I'm fudging. I should have figured out what I wanted to do here before I started. Okay. So let's just say you have this. Okay. Well, if I divide both sides by 900, I get x squared over 100 minus y squared over 225 plus z squared over 36 equals 1. And that, of course, is x squared over 10 squared minus y squared over 15 squared plus z squared over 6 squared equals 1. Now, what do we have? That square almost looks like a z. Shouldn't be confusing, but it could be. There we go. Okay. Okay. In the first place, we can find the x, y, and z intercepts of this equation. The x-intercept occurs when x is plus or minus 10, the two x-intercepts. So, I'm not going to label all three coordinates because it might get in the way, but I'm just going to put a 10 here and a minus 10 here. We know that these are going to be intercepts, and the 10 and the minus 10 are x coordinates. I should write 10, 0, 0, negative 10, 0, 0, but for space reasons, I don't want to do that. I'm inevitably going to write something that gets in the way. So the less I write, the better. Okay, y intercepts are negative 15 and 15. The z intercepts are negative 6 and 6. In the xz plane, you have an ellipse. Well, I don't want to, maybe I do, but probably not. I don't want to confuse things by sketching the rectangle. I'm going to do it anyway. Okay, so you have a rectangle like this and like this. This line is this long, right? Centered here. And then we connect these points here and connect these points. Right there is a rectangle in the xz plane, and within that rectangle I can sketch an ellipse. Now the key to doing a half-decent sketch is to make sure that the ellipse is tangent to this rectangle at these 4 points. I didn't quite get that right here, but it's pretty good here, here, and here. Anyhow, can you visualize where that ellipse is? Okay, so if you've got x, y, z, the ellipse is in the xz plane, so here's your rectangle, and here's your ellipse. Okay, that's great. Okay. Now, in the xy plane, you could also draw or sketch the rectangle. I'm going to sketch it very lightly because I'm kind of not getting the right points there, but I think I understand what it is. Okay. In the xy plane, the ellipse is going to go, you're going to have a hyperbola because of the minus here. A is 10, B is 15. Well, there's your rectangle. It's totally consistent with what we saw up here. And your vertex is going to be on the x-axis, your vertices. Okay, the two vertices are going to be here and here. And your asymptotes are going to be here and here. Well, I kind of missed that corner, but okay, you get the idea. I didn't draw the thing very well over here. This 10 was smaller than this 10. That threw me off. Of course, I threw myself off. So the hyperbola is going to go through here and come out asymptotic to these lines. I kind of cheated on the shape of the hyperbola, so I missed that 6, but you get the idea. Okay? And then what about the YZ plane? What have you got there? Well, again, you've got a hyperbola. Figure's going to get a little messy. But you would have a rectangle kind of like this, like I say, messy. And you're going to have a hyperbola here as well. Now the figure's getting almost impossibly complicated, so I'm going to sketch the hyperbola in the XZ and the XY plane here. So this is all down in the XY plane. Now you're going to have a hyperbola in the YZ plane. I have asymptotes here and here. And I'm going to include the Z here. And that's going to get just about impossible to draw. Okay. There are better ways to draw these, but you get the idea. Well, that's an ellipse and two hyperbolas. What happens if you're, what happens if you're not in one of these coordinate planes? You're not in the XZ, you're not in the YZ, you're not in the XY plane. So let's take the same let's go up to the plane where Z equals well, I'm just going to go to Z equals 3 because there's no good set of numbers that I can put my finger on quickly. Okay, in the plane where Z equals 3, I'm going to go ahead and write out these numbers. X squared over 100 minus y squared over 225 plus (1/4) equals 1. Where do I get the 1/4? Well, Z is 3. You got 9 over 36. That's 1/4. So this equals 3/4. put this in standard form, you have this. Well, 4/3 of 100 is 133.2, repeating, right? Maybe better, the square root of 4/3 is 2 over the square root of 3. 2 over the square root of 3 is 1.732, but I don't need that many significant figures. So I'm going to say maybe that's 11.6. Instead of 10, which it was before. Now wait a minute. And that is totally screwed up. I'm going to rewrite these two lines. I did my arithmetic wrong. You divide by 3/4. So you're multiplying by 4/3, of course, but the 4/3 does not appear in the denominator. You get because you're dividing by 3/4 to get the 1 over here, right? Okay, square root of 3/4 is about I'm just going to kind of round it off 9 here, and yeah, I'm going to got to guess 8.7. Okay. And minus y squared over, I'm just going to say 12 equals 1. Of course, you can work out these numbers. Well, what you see from this is that